The Sun has a diameter of approximately 13,91,400 kilometers and is composed primarily of hydrogen. The Sun's core is an astonishing 2.9 crore degrees Celsius, while the pressure is about 100 billion times the atmospheric pressure here on Earth. Under these conditions, hydrogen atoms come so close together that they fuse. Right now, about half the amount of hydrogen in the core of the Sun has been fused into helium. This took roughly 4.5 billion years to accomplish. When the hydrogen is exhausted, the Sun's temperature at the surface will begin to cool and the outer layers will expand outward to near the orbit of Mars. The Sun at this point will be a red giant and 10,000 times brighter than its present luminosity. After the red giant phase, the Sun will shrink to a white dwarf star about the size of the Earth and slowly cool for several billion more years. Sunspots are temporary spots on the Sun's photosphere. They seem darker than the surrounding area since they are regions of reduced surface temperature caused by concentrations of magnetic flux that inhibit convection. They are planet-sized regions of strong magnetic fields, and they can spawn eruptive disturbances such as solar flares and coronal mass ejections. There, the magnetic field is about 2,500 times stronger than Earth's, much higher than anywhere else on the Sun. Because of the strong magnetic field, the magnetic pressure increases while the surrounding atmospheric pressure decreases. This in turn lowers the temperature relative to its surroundings because the concentrated magnetic field inhibits the flow of hot, new gas from the Sun's interior to the surface. Sunspots appear within active regions, usually in pairs of opposite magnetic polarity. Their number varies according to the approximately 11-year solar cycle. The frequency and intensity of sunspots visible on the surface indicate the level of solar activity that is driven by the Sun's magnetic field. The surface of the Sun is a very busy place. It has electrically charged gases that generate areas of powerful magnetic forces. These areas are called magnetic fields. The Sun's gases are constantly moving, which tangles, stretches, and twists the magnetic fields. This motion creates a lot of activity on the Sun's surface, called solar activity. Sunspots have two main structures, a central umbra and a surrounding penumbra. The umbra is the darkest region of a sunspot and is where the magnetic field is strongest and approximately vertical or normal to the Sun's surface or photosphere. The umbra may be surrounded completely or only partially by a brighter region known as the penumbra. The penumbra is composed of radially elongated structures known as penumbral filaments and has a more inclined magnetic field than the umbra. Within sunspot groups, multiple umbrae may be surrounded by a single, continuous penumbra. Due to their correlation with other kinds of solar activity, sunspots can be used to help predict space weather, the state of the ionosphere, and conditions relevant to shortwave radio propagation or satellite communications.